spatial computing, augmented reality, and AI agents are basically, poised to be the biggest revolution after mobile. And the tech giants are really making strides toward that. But we are reaching the limits of physics. We're reaching a physics wall. So I'm Theo Marescaux. I'm the founder and chief product officer of Swave Photonics. So at Swave, we're basically aiming at going through this wall by using sub-wavelengths, nano-pixels, to enable true holography. And the purpose of that is to replace optics with computation. So we're moving from personal computing to mobile. That was a huge revolution, and indeed, we're moving into the space of AI power agents, and we're going to have those pervasive everywhere, and we will have to interface with them. And the best place is the visualization system. And the wall I was mentioning before is that existing display technologies, if we want to apply them to real-life AR, are bulky, geeky, expensive, power-hungry. It's very inspiring to see pioneers like Meta and EssilorLuxottica making huge strides and introducing products such as the Meta Ray-Ban display glasses. At the same time, these are still monocular. They have a certain weight, around 70 grams, and they have a flat combiner. And Eric from Engo earlier on has explained a lot of the challenges that we have to make these glasses really lightweight. And this is exactly the kind of hurdles that we're looking forward to solve at Swave. And this is our vision. So we need glasses to be fashionable. We need them to be a medical device. They're prescription glasses, and they're human vision friendly. So by fashionable, it means that they need to be lightweight. The frame is thin, and you would need to have curved glasses. Also, in terms of prescription, 60% of the population requires prescription glasses, so we cannot forget about those, which also means that we need to keep the lenses thin. And as Eric was very nicely explaining, when you're having a flat waveguide, you're ending up with thicker lenses, which is an issue, right? Also, very importantly, it has to be working with the way that the human visual system works, which means that it's binocular. And if it's binocular, you also need to be able to show the information without giving you divergence accommodation conflict. And so that means that you have to be able to dynamically modify the depth at which you are projecting. So the solution to that is actually holography. Not only because holography is cool, but it's also because it allows you to replace optics with just pure computation. Now, Swave is bringing two big revolutions. We are a spin-off from IMEC. So we're basically backed by over 10 years of deep R&D at IMEC. And I would say the first really innovation is a pixel technology. A pixel technology that is smaller than the wavelengths of the light that is impinging on it. So we are using a CMOS process technology, 300 millimeter wafers, that we're covering with phase change materials that we use as a pixel to achieve a pitch of less than 300 nanometers. The other breakthrough is on the compute side. If you want light glasses and you're replacing optics with computation, well, you have to be able to do the computation in real time and at low power. And this is exactly also what we are developing. We're developing a compute chip to do exactly that. Now, phase change materials. What are the phase change materials? These are materials that have two physical states. And when I'm saying phase is it's a solid phase. And there is a crystalline state where the atoms are nicely arranged into a lattice. And there's an amorphous state where the atoms are not so nicely arranged, and the electron distributions between these two states are different, which means that their optical properties are also different. And we change from one state to the other by gently heating the material. Importantly, these two states are stable. Right? So once I have configured my material, in one state, it's going to stay there. And that's very important for low power consumption, because in between frame changes, we completely power off the chip, and only the light source is consuming the power. Now, these are actually not new materials. These are the materials that were used in